more details about main principles of object-oriented programming. And what are these main ideas of object-oriented programming? As I told you already, main idea is that you structure your code and design of your software by thinking about things you need to manage before you start managing them. And this is complete opposite of other paradigms or programming approaches, because you may look on these things in different ways, and if you look on history how this programming developed, then first approach probably is procedural programming. Which means that instead of writing everything as a very long wallpaper of instructions, you make a structure inside it, that you wrap up some of instructions in procedures, and then you call one procedure from another to deal with all these complexities. And then after this approach, different paradigm was invented, which introduced different kind of limits how these procedures, what they call functions, and why these are called in different ways, because every time some new idea is invented how to make your work more reliable, more efficient, etc., they want to stress difference between previous approach and new approach, and they usually rename related and similar things in different way, just to stress and this important differences from previous approach. So function and procedure in general is the same, but how you use it and how you look on them, of course, is different. And for functional programming, my idea was that many errors coming from programming comes from remembering state. And what is state? State is thing that you have something like account, and you have balance in it, which is one thing of your state. It may be closed, it may be open, all these things are state. And every time you need to change and remember state, you may introduce quite a lot of different kind of errors, because many things, how it works, depends on state. And in functional programming, everything is recalculated from scratch. Instead of remembering something about object here, you call function. And later this approach was renamed when it was reorganized declarative approach, and this was renamed imperative approach. And one of these declarative programming language is functional programming. One of very important programming language is like Lisp and maybe Schema. And from more modern programming languages, this Clojure. But For procedural programming or this imperative approach where you for declarative programming you just say what you want to get and there is function for it. And one very important, which is still very widely popular, is we will talk about this later, is structured query language for databases. Also is maybe not functional approach, but this declarative approach. You say what you want to get, but you do not say step by step what you want to do. And for this procedural approach, object-oriented programming is subset of this procedural or imperative approach. For example, here you can say it is, let's say, Fortran as old programming language and Pascal. And for object-oriented approach, it is still this imperative approach, but to deal with these complexities about account and state, it introduces that you start with strings. Strings are first, and then methods. How to deal with this later. In this functional approach, it is only functions. If you want to get a string, you need to call function, which will return you this thing. So things are just temporary objects or temporary data structures, which you get with this functional approach. And so at that time, it was quite a new idea, but the idea was that you deal with all these complexities and design your software reliably. You first need to be very careful and understand what kind of things you are processing. That means you need to describe your objects, their internal data structure, their relation each to other, how object is related to other object or refer to other object, and then you describe how exactly they will behave, you describe their methods. And how do you do in Java? You always create classes, and in old school Java that was only thing you could create, but of course real life becomes a little bit more dirty and complicated. You can also create enumerations, you can also create records, you can also create interfaces, but in general the main and important thing what you create is classes which represents these objects and their behavior, and then to create objects from these classes you use constructors. To do something with objects created out of these classes you use members. A member is total name between properties of object and methods of the object. Then you use abstraction to inherit data structures and behavior from more general things, and you use polymorphism to manage similar but different objects with the same approach. So if they have common ancestor and they are similar, and you may ignore small differences, you can manage different objects using absolutely the same approach. And then some design principles. Usually in object-oriented programming you start from top to down. This means with very large and general things, and then you describe them later in more and more details. And then you may measure cleanliness and consistency of your design using two very high level quality metrics. One is called cohesion and another is called coupling, and then you can put things together, which is called composition. So all these are main concepts you need to understand to be fluent in object-oriented design, object-oriented programming, and hopefully you will have at least some understanding for each of them after this class. So class is the main thing in object-oriented programming. You have seen and have created some classes in this bootcamp already by yourself. It starts with modifier, which is access modifier. I will talk in details later. Class keyword, name of the class, always use uppercase, and its body. And class allows you to put things inside things or to refer to other objects or instances of other classes inside body of current class, and you can inherit some things by extending classes. We'll talk in details about this later, and you can use this polymorphism or similarities of different objects to manage them in similar way. Naming convention in Java is that you use so-called camel case if name of your class has several root words like savings account, interface account. Class name always starts with capital. I think you can compile class named with lowercase letter, so it's not compilation error, it is just a quality error, so you do not follow Java standards. And here is example of some class called vehicle, and it is public, so everybody can refer to objects of this class and refer to this class to use it, but it has some private internal data structure, in this case double, which is double length integer maximum load, called as max load, and it has public setter to set this load as a method, so you cannot reach this property of this vehicle object directly if it is not inside code of this class itself, but you can set this property using this setter method. And then inside this body of the class you put different kind of attributes or properties. They may be public, private, protected and other things, and these may be primitive types or complicated types, and if these are complex types like string, then this means that your object actually refers to other object. In business terms you may say that there is object inside that object, but it is business term. Practically it means that object from class foo refers to object from class string. But you can also say that it's there is string inside this foo, because when you ignore what is inside what, then of course you can collapse internal structure of this project of this object, and then when you expand it, then you can imaginately go into internal structure of this object. And all attributes are always inside body of the class, and even if you want to create something like global variables or constants, which you sometimes put somewhere in the top part of your procedural approach like in Pascal or BASIC, in Java also such commonly accessible data structures are inside body of some class, so there is never any properties outside of the class. You will get compilation error if you will try to do this. Here we have, for example, two global variables. This int const may be considered a global constant, and this int var may be considered global variable. And Then, in any non-trivial Java project, you need to deal with bunch of similar items. In jargon, these are called objects. In non-jargon, more precisely, these are called instances of a particular class. Why it is jargon? Because when we'll go into detail, there is also a class called object. And class object is common ancestor for any customized Java object you create. For example, if you create a class customer, it implicitly extends or refers to class object. And so here you have clash of naming convention. If you refer to this class named object, or you refer to object created out of this customer class. And therefore, more precise term is that you create instances of your customer class, and you create instances using new keyword and constructor like new customer. So in jargon, you may say that this is your object of your customer class, but in more precise terms, it is instance of your customer class. And as you probably remember from yesterday about this Black Knight class, you create these objects using class as a template, and also you should remember that when you create this new instance of your customized class, some of its properties are used as a template for internal structure, and this will be inside body of the class, but outside any method, no static keyword. But some will be used as a common data structure, which will have this static keyword added. So with static keyword, it belongs to the class, and similarly to the methods. If this method do not have static keyword, then after you have created something like, here you would write customer, customer is new customer, and you say customer method. So if this method do not have static keyword, then you change behavior or do something with particular instance of this particular object. And of course, such customer objects may be hundreds, thousands, or millions. But if this method has static keyword, then if you are ceremonial, you can write customer and some method. So this method will do something with maybe many customer objects or etc. So static structures belong to the class. Non-static structures belong to the objects, and non-static methods are used to do something with one particular object, but static methods are used to do something with class. Typical static method is public static void main method. So you execute it just by having this class. Remember, main method is static method, and to run static method, only thing you need to have loaded definition of your class inside your virtual machine, or more precisely inside memory of your Java virtual machine. But to call non-static methods, you need to create instance of this class first, and then you can call it. And you construct these instances of your classes using constructor, and for some decision, Java designers decided that calling just constructor is not enough, probably to make their life easier for compilation. and to make a compiler easier. Before this calling constructor method, you also need to add new keyword. So I think there could be possibility to create Java compiler which doesn't need this new keyword inside constructor, but one thing is probably it made their life easier. Another thing, in Java's old programming language, before that you didn't have syntax highlighting and similar things. Probably this new keyword could be used as an indicator and easy to catch flag to see, this is constructor, it is just not some static method called or whatever. And so in such way you create new instances or new objects, but all the static structures are created implicitly when you just load your definition of the class inside your virtual memory. And any customized Java object has default constructor, and default constructor works in such way that data structures for your object are created, but all their properties are empty. For example, if I have some internal data structure, actually it's more interesting to write in the following way. I have several run configurations. I don't need several. So, the val constructor works following, that it creates and reserves memory inside Java virtual machine to hold necessary values for this particular object, but their values are all zero. For example, if we also add boolean, then you'll see that boolean value 0 is considered false, 0, 0, 0 for different kind of objects. For character it is null character or 0 character, and for objects you have only reference created which refers to nothing, to null. So that how default constructor works. And if you are not happy with this, then you create your own customized constructors, for example, to create default values to something else. So, for example, you can do something like this. And then you do not have default values, which are all 0, which means either 0 as a number or interpreted 0 like false or null character for characters, and null references to the object. But now I have created string s here and Java object here. And remember that what I did here is the same as new string, but because strings are so widely used in Java, they override this assignment operator in such a way that you can assign some value without ceremonially creating or constructing a string object. But it's not true for any other object. For example, to create a Java object, you have to do this. And if you want to know what this Java object is, it doesn't have any internal data structure, so it doesn't have any fields, but it still has some properties. For example, you see that it has short list of some methods what you can do with this created object. You check equality, you could get reference from object to its class, and this is how you know that this object belongs to this class. And every time I'm talking here about object, I actually mean instance of object class, because a real object is this object, class called object, or more precise. So you can do a few things with this Java object. For example, convert it to string, etc. And of course, constructors may have parameters, and then you set some values of your instances or objects to some passed arguments here. Again, if you want to be precise with convention, it is following that when you declare some method and you put some passed values here, these are called parameters. When you actually use them and pass these values are called arguments. So declaration of these arguments are called, to be precise, parameters. Actual values passed when this method is called are passed arguments. But again, most of practitioners do not distinguish these terms. And what is important about objects particularly is that objects consist of two parts, reference and structure of actual data. And if you do something like this, when you use two different variables to refer to the same object, and in this case by object I mean instance of my test class, then you see that these are actually the same objects, because what I have done here, I just added another reference. And in my programming language, this reference has nice name, test and test1. They both refer to the same internal data structures when these data structures were actually created. So here is other example, x and y variables for integers and s and t for objects. When you create object which you refer with variable named s, here you have this reference part, but when you construct it, your data structures are here, for example, 3 kinds of integers, and when you say t is s, you create another reference, but actual data structures are not recreated, they refer to the same place. And if we go in more details about memory, it is why it is done in such way to make automated management better. So here is entire virtual memory of Java. It starts with some small number but not 0, and finishes with some large number, who knows how large. And here is the stack part of memory, and here is heap part. Every time you create local variable, this means inside some block of code, it is put inside as a stack. And stack memory is easy to manage and works pretty fast, because every time you create some new local variable, you decrease stack or increase from upper part of memory to lower part. And when you call method from method, for example, you have m and int e passed here, you put value of int e here, and you add return when you go back from this method to previous method where it should continue. And when you go deeper, you add, and when you go back, it automatically just jumps back to this stack until public static void main method execution of this method is finished. And if you create local string or local variable which is object, then reference part is still put into stack. So every time you create local object, the reference is still managed very quickly, nicely and reliably. You just add more references into stack, but actual values of these references, if it's string, then you have some array of bytes with some value, let's say 3 bytes and A, B, C. And then this reference refers to that part inside heap. If you create some other object like customer, again, reference is added in next free cell into stack, but actual value is, for example, if it's customer, it has bunch of numbers here for actual data structures. And every time you go back to called method, you just decrease length of stack, and you know that everything before that part of memory is free to use again. But what is about heap part? And heap part is much more complicated. So here garbage collector comes in. There are many Java threads running in your virtual machine, but one important concurrent parallel thread which is working inside virtual machine is garbage collector. And garbage collector inspects all these data structures in heap part and checks if it is some loaded class which is not needed anymore, so it unloads some class definition. And also checks all these data structures. If there are some data structures which are not referred by any reference, then it cleans up this memory for all this data. And that about local variables. But if you create global variable like static structure, okay, if I write codes here, then the static structure is always also reference part is somewhere here in heap part, but it still has reference and actual values. And because these static structures are loaded together and created together with class, then of course these values are always inside virtual memory, because you will always have at least one static reference referring to actual values, so these will never be touched by garbage collector. And that's one of the reasons why static structures are considered bad. You use only when you really need to use them, because otherwise you just have too many data stored all the time inside your virtual memory. See a comment. It just marks memory. Garbage collector marks memory as a free. It doesn't delete anything because it is just extra amount of time to do. So if you have some security issue in Java, etc., then you can still read some data which are considered deleted, because it's something like for file system. When you delete file, actual data are not overwritten by zeros or random garbage. If you know where to look at, you can still read deleted files, and this is how undelete operation works. So, and when you pass some parameters to methods, so when you pass these parameters, these are added as new cells to hold values in this stack part of memory. And how it works for primitive types, because these are short and fixed lengths, direct values are passed or copy of data is created. For example, if I say now test M1, and let's say 5, it works in the following way, that when method M1 is called, and maybe we can try to look how it looks in debug mode. So when M1 method is called, and this belongs to object because it doesn't have static keyword, so I need to have a reference to object created first, and then I can call a method particularly for this object. This primitive value 5 is created as a new copy, as a passed argument for this method. But if I pass object to called method, and in this case object is string, then here what actually is passed to this method is reference to this value. And so this means that here, if you try to distinguish this, you may say that it's passed by reference, not passed by duplicate. But what actually is happening here is that you can look on this in different way. That passed arguments in methods are always converted to primitive types. So if you actually pass primitive type, then copy of this value is passed to the method. If it is object, as in this case it's string, then copy of reference to this object is created, and because copy of reference will still refer to the same object, as here, so you create copy for this reference, the number will be the same, and when you will use this reference in C, they say dereference it. Of course, they will point to the same actual data, and so it will be point to the same actual object. So inside member methods or methods which doesn't have static keyword, you can use this keyword, and this keyword inside member methods means that you refer to this current object. So what is this in this case? When I call M1 from here, this refers to test. When I call M1 method here, then this refers to test1. And if you are not sure, do you understand completely what this means in this case, try to create some short Java code like this and try to execute it. And you cannot call M1 directly without creating instance here, because you get compilation error, because M1 belongs to the object. So you always have to have reference created first, and only then you can call it. And so this keyword in this case refers to that reference you have created earlier. And if you have some static method, then of course you can call it directly. A ceremonial way would be test M3 in following way. Or you can, inside body of current class, you can just say M3. And this of course will work only if my code here is inside this class. But if I create some other class, then of course I have to be ceremonial. I refer to class test and to method M3. And when you start working in large projects and you have to do your small contribution, you should always learn two different types of navigation, from actual usage of variable, method or whatever to its declaration. And with context sensitive menu, right click here and for example go to declaration for entire workspace, for example, and search for it. Or if you just want to navigate to it, it is F3 in Eclipse, and I do not know, something like Ctrl-Shift-B in IntelliJ IDEA. And other thing is that you want to get all the usages of this method inside your project. So two opposite directions, from usage to declaration, F3 in Eclipse, and from declaration to usage, Ctrl-Shift-G in Eclipse. Very important navigation features you should know when you need to explore some existing code and add something into it. And I use this quite a lot. So that's about this. About destructors, very easy. There is no destructor in Java, and that's a good thing because you don't need to care about virtual memory by yourself. Everything is destructed by garbage collector, but in some more complicated code you may signal to Java virtual machine, to this garbage collector thread, that it's good idea to do garbage collection now. And you can do this to override finalize method for your objects, or you can say to garbage collector please run now, using two different interfaces, runtime.gc method or system.gc. What means these two different interfaces? Means implementation is absolutely the same, but entry point or references, how you can refer to this method, are two different ones. So then you have methods in your object, and I talked about methods quite a lot. Now some overview about them. So where is the difference between constructors and methods? Constructors do not have return type, so even though Java is very verbose language, it is not completely insane, because if you have some constructor here, you of course would write something like this: public test, where here is name of your constructor and here is return type, because it returns object of the type test of this class. And Java is quite famous with this particular one already. Test, new test, and here we can pass, for example, string s here and say it is s in this case, and then we can write something like test here. What's wrong with this? Because now it's not considered a constructor anymore. So test, and test. And Java is famous with such abracadabras, where syntax highlighting helps a lot, but this is type of an object, this is name of this object, this is constructor, and this is passed parameter. And what also helps here is lowercase, capital case letters, and of course double quotes here. So they decided that return type to constructor is just too insane and too verbose, so no explicit return type, but of course it returns type of this object. Then name for constructors is the same as a class name. This means if you follow Java rules, it will start with capital letter, and this keyword refers to another constructor. I think it will be important for next exercise, but we can do something like this. And we can say this. For some reason, they decided that the same keyword will be used in two different ways. Dot, this and dot, and this and bracket. This and dot refers, it works only for these member methods which do not have static keyword or refers to current object, which is either currently constructed as inside constructor or currently managed as inside normal method. But Java designers decided that this with opening bracket inside constructor will refer to other constructor. So what is happening here is that when test is called without parameters, then this constructor calls that constructor and passes this fixed value as an argument for its input parameters here for this constructor. And also Java designer decided that constructors are not inherited, so if you want to inherit, then you need to say it explicitly, and you do something like this. So if you have class test text extends test, then you can create constructor and refer to superclass, and superclass in this case is test class. Okay, maybe refactor it to extended test. So that's about constructors and about methods, how more different access modifiers, how any returned type or void, so it does not return anything, you have to explicitly say its type is void, and differs from class name, usually starts with lowercase letter. If it's static, it may start with capital letter. It depends on formatting rules of your project. This refers to current object, you write this and dot. And of course it cannot be used in static method because in static method you do not have a current object. And methods are inherited. So here I have to write my own declaration of constructor if I want to refer to super. But all the methods are inherited. For example, I can nicely call m1 with some value. And if I go to declaration of m1, then it immediately shows me that this method is not declared in this current class, but it's is declared in parent class or test class. So then when we talk about encapsulation, we did it already yesterday for this random person. We may create internal data structures private, and then we may create public getters and setters for these fields. Why do you use this is because in most of times, for example, you have some class person and it has int age. Looks good to you, but problem with int is that Java doesn't have, at least still older versions of Java, do not have unsigned types. It has only signed types. This means that you can create person for age which is something minus blah 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 blah. And of course this is very wrong. And what do? You create it private and then you create public, set age with some int age, and then inside this set age you do validation check. If this age is negative, throw exception, do nothing, set to 0, whatever. But then you can deal with these complexities that usually ranges of values what you can hold in your data structures are bigger and maybe crazy according to your business needs. So you encapsulate them. Encapsulation means hiding, put inside it but do not show. And then you make public access only through these methods which you can control. So that is what encapsulation is. You put your data structures, make them inaccessible directly because you may need to have specific behavior, but then you add these accessors or getters and setters to access these values, and in methods you can control how exactly it happens, because in method you can write whatever you need to write. And so I showed you inheritance already in this example. In plain English, this means that my test is also a test, but it's a little bit more complicated. Currently I do not have any more complexity here, but I extended it. And it is very widely used in object-oriented approach because you start with some simpler things and then you go in more detailed things. What is very important about inheritance is that if you do your design properly, you always add complexity. So that means you start with Java object which doesn't have any internal properties at all. It has few methods, for example, to convert it to string automatically, to check is this the same object or whatever, and then from Java object you can create animal, you can extend animal to bird and fish or mammal or whatever, and proper design is that you always add complexity. And what means add complexity? You can add more values, like fields properties, and you can add more behavior. So this is proper extension of previous class test. Test has following internal fields and following list of methods. And of course you can look it here in Package Explorer as well. And this extended test, X-test, has more fields and more methods, or it may override I think M1 was integer. Let's go. Int. So that action, I want to refer to in following, right? It is void. So first we can print like this without line break, and then call that one. And when we run it, where is my E? Wasn't it printed out? It changes it. Okay, so but you got idea. So this is proper extension. You add more properties, fields, values, call whatever you like. You add more behavior, or you add more methods, or you create some of inherited existing methods more complicated. And if you need to hide something, if you need to remove something, if you need to remove this complexity by extension, then you are not working with your design according to the object-oriented principles. And composition is putting something inside something. And this is composition. And composition is friendly with encapsulation, because if I do following, This is encapsulation. So you put things inside things or compose them, and when you start putting objects inside objects, then of course this composition may be very, very deep, because some objects may have some other objects inside them, so this composition is quickly becomes quite complicated. And if you hide them and allow to access them only through controlled methods, then you encapsulate them. You put them into envelope and close this envelope so these are not visible. And what is polymorphism? Polymorphism is that you have different objects which are similar and you use them in the same way. And very great example of polymorphism which we can visualize is following. So object-oriented approach is very friendly, at least in my opinion. It is probably not needed all the time. You can do object-oriented approach everywhere, but I think you are required to use object-oriented approach to deal with business process management or business process automation or simulation, call whatever you like them. So when you have distributed entities or these agents somehow dealing together, like your customer's invoice and etc. Another thing where I think you have to deal with object-oriented approach is graphical interfaces. And for example here I have several different objects, but they are similar because they are similarities. And what are similarities? I can resize them in the same way. I can move them around in the same way. I can change some of common properties of them in the same way. For example, change line for them, change area of them. And if I would have something different, for example just line, also together with this is a little bit different object than that, because lines do not have area. But if I still check them, so I cannot change area of lines, I can change only area of this. But if I change lines, it's still changing. So if they have similar properties with the polymorphism principle, that even these are different, if they have some similarities like set color or set border or line, whatever it is, still works absolutely the same way. So this is very great visualization of polymorphism. And similarly, for example here in extended test, I can create extended test, well, let's call it X test. You see that I can manage both these. Okay, let's say to see what is happening here. that I can use the same method here for similar but actually two different objects. What I'm surprised about now is where is this more complicated went. I ran wrong test. And here you see it. And then I don't need ln here, but just this one. Oh, that surprised me. So that's about polymorphism. And as I told you, in object-oriented approach, usually you start with top-down design. You start with large, complicated, general things, and then you design them down to more primitive things. Usually in Java, because Java has also primitive types, you end up with structures which sooner or later have only primitive data types here. And primitive data types, of course, do not have methods for them, only objects have methods for them. Primitive data types allows you only to hold values. So that's how you do it. And of course, sometimes you need to understand when you need to extend and when you need to compose, when you put things inside things and when you extend. And you can do some guidelines, but sometimes it is also art, not only science. And to understand better how to distinguish between insane art and sane science, you can use different metrics. And one of good metric is a metric called coupling. And coupling is a metric which shows you how many references you have between something. And good example of coupling could be something like this. And here we call this method and it even works. But it is design is quite insane because you have this coupling. Coupling means following thing. Either you refer from method to method to method to method, and even more insane coupling would be okay, test one. So this hidden knowledge how it works is even in completely different class. And here you can make bad coupling by yourself. And when you need to debug it, for example, you run it, and sometimes it works and sometimes it doesn't. Okay, let's print also it. And this is coupling. So first we have too many calls from method to method. Second, we have hidden dependencies, and this is another example why public static ints are considered bad, because then everyone can refer to it and you cannot see data flow directly. Not seeing flow of data or flow information exchange is always bad. And so this is bad coupling. How can you refactor it? If you need to have this behavior depending on some value here, to revert bad coupling you would have something like this. So behavior will be absolutely the same. See, output is absolutely the same, but now we exactly see what is happening. That in this called method there is some checks, which checks for some conditions, etc. And if these conditions are met, it does this. If these conditions are not met, in this case it doesn't do anything. And we see that directly flow of data which will be checked for these conditions comes from this method here to here. So this is minimized coupling because data flows are easily to see and no stupid and strange calls from methods to methods. So this is about coupling. And when you talk about coupling, I told you about minimize coupling and always add complexity, particularly for graphic editors. For graphical editors, if you start with geometric approach in your business process is something like this, that for example you have 4 corner shapes let's say objects. And in geometry, usually they start with objects which are very abstract, general case, and then you reduce complexity, and first you can say that, for example, it has at least two parallel what is called edges, then maybe all parallel edges, and then maybe all edges are the same size. So this is general case, and this is trapeze, how it's in English, trapezoid, and this is rectangle, and this is square. Particularly in geometry, they remove complexity, and this is specific case of that, which is specific case of that, this is specific case that. So this is how you usually talk in geometry. But if you will start doing something like this in your graphical editor, you may first have set of setters just to set for arbitrary points for this shape in any place. So this means something like set 1, set 2, and set 3, and set 4. And if you do extend this, so for example you have this trapezoid extends just call it shape, then you need to add coupling, for example, that when you set these points, they actually have to be parallel to that point. So you add some more rules and conditions, and then when you set these points, you cannot set fourth point here, you need to add some restrictions. So you, instead of adding complexity, you add restrictions. And that is bad. This is coupling. Because coupling means, for example, in square, you just resize one point here to that. This means all your shape actually needs to be resized bigger, because it still needs to be square. And this is very confusing. And this is another example of bad coupling, that when you do something, there are some hidden behavior. For example, if you move just one dot here or node of this square, all other places are also resized because it still needs to be square. So what you do about this, because in proper object-oriented approach you do not add restrictions, you add complexity, you do not extend general shape to trapezoid, to rectangle, to square. Everything in this is just a shape. And square is different. And then, if you like, you may extend square to the rectangle, like rectangle extends square. But it depends. This would be same approach, but it has other drawbacks. So remember, every time your business rules removes complexity and they talk about specific degenerated cases, in more general cases you shouldn't do extension when you go from more general cases to more specific cases, because if you add restriction, then that is bad design. You need to add, in most cases, add freedoms, not restrictions in your extensions. And cohesion is about similarities. And how you check cohesion, in general this means shorter code and more sane design. For example, you may have consistent rules for your design, which is not cohesive. For example, you do following. Every time you need to introduce new representative class for your objects, you do following. If you like these things for your management or simulation system, you extend it from class myLikes. So you like bad fish and potato, you extend myLike. If name of class starts with C, then you extend starts with C, and everything else extends other. And if you need to introduce class car according to this rule, where it should go, if I don't like it, then it extends start with C. If I like it, then I extend myLikes. So still consistent design. You can always follow these rules and decide how do you do extension, encapsulation, etc. But of course it is very sane from design perspective or from this cohesion perspective. And cohesion means that similar things should be put together. Similar things usually tends to extend each other. And different things may refer to different things, but they do not extend them. And with good cohesion, you have shorter code because you can rely on similarities as much as possible. And also you have less coupling, what means you have less unintended consequences or unintended dependencies between these objects. And so, as I told you already, every time you introduce your own custom class, you implicitly extend the Java object. So writing class employee extends object is the same as just class employee. And as I showed you, Java object doesn't have any internal properties. So when you work accordingly to object-oriented principles, you can add some complexity to Java object when you need. But it has some implemented methods already implemented. One of these methods is the string method. For example, if I have it automatically converts any Java object to the string in the following way. That first it shows to which class it belongs, and second it shows where it's located in virtual memory. And if I say you will see that this is the same object because I just created different reference pointing to the same data structure. But if I will say to create new other objects, then I will see other objects. And if I create a customized object, it works similarly. It shows in which class it belongs, and because here I do not have a package, I use default package or no package at all, it is just class name and where it is located. But that is problem because if I have some internal properties and I say, for example, I don't see any internal structure, I need to go to debugger, for example, to look inside it, and debugging do not work all the time because of timeouts and other limits. So of course here I see it. Usually what do? You override to string method and you do something like this. Generate a string, and you say, for example, use all internal fields for it. Remember that methods which are not constructors are inherited automatically, and it works in the same way for any custom object. But if you override it, then you see it better. You see that it's test object and its internal fields, values of internal fields or properties are following. So we will also need this in our practical exercise. And that's it about initial concepts about object-oriented programming. Do you have any questions or comments so far? I take that as a no, and that means we have earned some break. Let's make break for approximately 15 minutes, and then we will look in your practical exercise.